I have found the ugliest algebraic challenge question in the history of mankind. Check this out. Here's a guy by the name of Aaron. Aaron stands on the roof of the tall building and throws the tennis ball up into the air. So here he is on the height of this tall building. There he is standing right there. He's got a ball in his hand and he throws it in the air like this. Okay. On its way down, the ball just misses the roof. So it just misses like this and it keeps on going. So guess what? By just missing, we can actually eventually do something with that point. We'll get to that in a second. And then it falls all the way to the ground. So all the way down into the ground, there it is down here and bounces back up and goes along its merry little way. Okay, why did Aaron do this? I have no idea. But Aaron, I think you got to get a life, buddy. Oh, well, anyways, okay. So the interesting thing here is, look, this is a parabolic arch. Boom, just like before. But here's the problem. The height is given in meters, h, okay, the height of the ball, above the ground after t seconds. So this is our time right here, okay? And it's given by this quadratic equation. Usually when I give you a quadratic equation in chapter 3s and 4s, I would actually give you the p and q value. Not this time. That's what makes this incredibly ugly. It says after 4 seconds, the ball is 102 meters above the ground. After 6 seconds, the ball is only 44 meters, 44.1 meters above the ground. Okay, now we're going to ask to be finding all of these things. The maximum height of the ball, the number of seconds it takes for the ball to reach the maximum, the height of the building, the number of seconds it takes for the ball to hit the ground. You can't do anything until actually figure out this equation. That's the problem. This was all stuff here from chapter 4. We've got a whole mess to figure out first. Okay, so let's do this. H equals to minus 4.9 t minus p squared plus q. Sweet. Okay, so we've got 102 for the first one after 4 seconds. So we got a value here. 102.9 equals to minus 4.9. Time was 4 seconds minus p squared plus q, right? Right. Now, let's do the same thing to 6 seconds and 44.1 meters. Okay, I'm going to write it right underneath. 44.1 meters equals to minus 4.9, 6 minus p squared plus q. Oh, what a mess. So guess what? We have to expand these. We have no choice but to expand this section and this section, combine like terms, to see if we can make it at least a little bit more simple. Okay, so let's deal with this guy first. So there's 102.9 equals to minus 4.9. Let's expand this. If we expand this here, we got 4 minus p squared, which if you remember, that's just 4 minus p times 4 minus p. Do the FOIL thing, and if you do the FOIL thing, it actually works out to be pretty easy. This is 16 minus 8p plus p squared, and that's plus q. Beautiful, okay? That's what this is. Let's distribute this in. Oh my goodness, what a mess this is going to be. It's going to give us ugly numbers. I'm going to definitely bring up my calculator on this one. Okay, so here we go. Let's distribute this in. I got 102.9 equals 2. Okay, calculator, where are you? There you are. Minus 4.9 times 16. Okay, that gives us a value of minus 78.4. So this is minus 78.4, right? There's minus 4.9 times 8p. So I got to multiply that now by 8p. So minus 4.9 times minus 8, which works out to be positive 39.2, positive 39.2, plus p squared, well, plus minus 4.9 p squared plus q. Let's combine a few more things here. And you know what I'm going to do here? Real simple. I'm going to take this entire thing and I'm going to bring it over onto this side. So I've got 102.9. I'm going to add the 78.4. I'm going to subtract the 39.2. Oh, we forgot the P on that. So subtract 39.2P. And then minus, I'm going to bring that over. It's going to be a plus 4.9P squared. And I'm just going to leave the Q where it is because I'm going to show you what I'm going to do in a second. And you're going to be really impressed. Now, I'm going to combine 102.9 and 78.4. Those two can combine. Just to make sure that I don't make up any mistakes, I'm going to put that onto my calculator. So there's my 102.9 plus my 78.4, and I'm going to get an answer of 181.3. So 181.3, then that's minus 39.2p plus 4.9p squared. And that whole thing is going to equal to Q. Oh my goodness, what a mess. What have I found? What have I done? Oh my goodness. Okay, guess what? We got to do the same thing to this guy here, right there. Exactly the same thing to this one. Well, okay, the heck with it. Let's stop complaining. Let's just do it. That equals to minus 4.9. This is going to be, right, perfect square. 36 minus 12p plus p squared plus q, right? Distribute in. Let's go. Let's stop complaining. Let's go. Bring this over. Let's clear. Here we go. Minus 4.9 times 36 works out to be minus 176.4. So 44.1 equals to minus, what was it again? 176.4 minus 176.4. That distributed over to the 12 now becomes, okay, minus 4.9 times a minus 12 works out to be positive 58.8. Positive 58.8. Oops, wrong color. Positive 58.8 p minus 4.9 p squared, and then plus q. Bring everything over to the other side, so you want it q equals 2. Q equals 2. Bring it over. Minus 4.9 comes over, so that becomes plus 4.9 p squared. Bring that over. Minus 58.8. Minus 58.8 p. Bring the 176 over. That's plus 176.4 with the 44 that was already there. 44.1, which is already there. Now, combine like terms, okay? Bring the calculator up because I don't want to make a mistake, okay? Now, combine the two terms, which is this one and this one. All right, here we go. 176.4 plus 44.1 equals to, I got 220.5. That becomes 220.5. That equals to Q. This is 4.9p squared minus 58.8p plus the 220.5. There's your two equations. That one and this one. And guess what? According to systems of equations, all I have to do is substitute this guy here in for Q. Okay, so 4.9 p squared minus 58.8p plus 220.5 equals 2. I can barely read it. It's right up here. There it is. 181.3 minus 39.2 p plus 4.9 p squared. Why? Because the two q's equal each other, and that's what substitution tells you. Now, this looks really ugly, but it's not. Aha! Do you see what I see? I see a 4.9 p squared on this side and another positive 4.9 p squared on that side. Guess what? The p squareds are gone. Let's add 39.2p to both sides. Look at this, 39.2p added to this side and to that side. That's gone now, leaving you 58.2 P minus 39.2. And if you're like me right now and you're overwhelmed by this and you're a little tired, just plunk it into your calculator. 58.8 plus 39.2, and look what you get. Minus 19.6. So this is minus 19.6 P plus 220.5 equals to 181.3, and all you have to do so far now is continue solving. So subtract 220.5, subtract 220.5, bring up the calculator again, okay? Here we go. 181.3 subtract 220.5, okay? It gives you an answer of minus 39.2. 39.2, that equals to minus 19.6 P. Divide each side by 19.6 by 19.6. Oh my goodness, that cancels, leaving you a p-value of, I have no idea, divided by minus 19.6 ends up with a p-value of, oh my goodness, p equals to 2. Oh man, all that work just to find out that you have to P2. Okay, so now that we know the P, we can find out the Q. Go back to any one of these. I'm going to go to this one. All right? I love that joke. Okay, so let me erase this and let's take some room here. Hang tough. Okay, so now that P we know is 2, this is 4.9 times 2 squared minus 58.8 times 2 plus 220.5. That's going to give us our Q value. So, okay, let's bring that up into the calculator right over here. Okay, so clear this. Here we go. 4.9 bracket 2 bracket squared minus 58.8 times 2 plus 220.5, and let's punch it, and we get a Q value of, look at that, our Q value is 122.5. Q equals to 122.5. Now, what does this mean? Go back to the original. Go back to the original. The original was this equation, which means now H equals to minus 4.9 P minus, remember the P was 2 squared, plus, what was the Q value again? Q value was 122.5. That's now, whoops, a little higher, 122.5. 122.5. There's your equation right straight out of, guess what? Chapter 4 now. All you have to do now is plug that into your calculator and you can determine all of those things. Maximum height, number of seconds it takes for the ball to reach the maximum, the height of the building, and the number of seconds it takes for the ball to hit the ground. Let's do that right now. I'm going to bring it into our calculator. So I put it into my calculator here. I'm on Zoom standard right now, so it's not going to work out very well because we all know that this is the vertex up here, and I'm going to get 122.5. So I'm going to change my windows. Hang tight. I changed my Y window to be a maximum of 150. Why? Because I know that this guy is going to be at 122.5. That's going to be your maximum up there. That's the maximum height of the ball right there. I don't even have to graph that. I know this because that's my vertex. My vertex happens at a time of 2 seconds at a max, okay, seconds at a max of 122.5, because that is my vertex from chapter 4. Do you remember that? Okay, so the number of the height, okay, that maximum is done. The height is done, but now I want to find the height of the building. And remember what I said earlier. Remember what I said earlier. This guy's going to come here and it's just going to barely miss. So if you think about it, that's what I'm looking for. And if you plot this, guess what? This becomes your X, Y axis. So going back to my calculator, put this in there, I put the Y max, I hit the graph, and this is what I'm going to get. Bada bing. I want to find that height of the building, which is that point, which I can do that by going second calc, find me the value. value when x is 0 because it is a y-intercept. The height of the building is 102.9. The height of the building is 102.9 meters tall. That's it, right there, smack, beautiful. Now, the last thing that we got to figure out is the number of seconds it takes for the ball to hit the ground. Remember, when it hits the ground down here, that's when, guess what? Y equals to 0. So you, in fact, are finding an x-intercept. So going back to our calculator, second calc, find me that 0, which is down here, number 2. So there we go. Bring this guy over. Let's go. Where are you? There it is. All the way down to here. Look at that. Left bound. There it goes. Right bound. Calculate, and you find out it takes a whole 7 seconds for that thing to fall. So t equals to 7 seconds in that. What an incredibly long question. This is probably the longest podcast of the year so far at 16 minutes, but what a great challenge question to do.